Hello everyone, welcome back to Discrete Mathematics with Adila Krishnadi here. And in this video series we will talk about another subtopic of graph, namely subgraph and operations on graph. So here are the references and acknowledgements. So operations on graphs that we will discuss in this video series consists of underlying undirected graph of a D-graph, subgraph operation, edge addition and removal, edge contraction, node addition and removal, as well as graph union. So we'll start with the first one. Underlying undirected graph is an operation to obtain a non-directed graph from a directed graph. So to be more precise, if you have a directed graph G with the set of nodes phi and the set of edges E, with the source and target function, then the underlying undirected graph of G is G prime with nodes in phi prime and edge in E prime, and the connection function st, such that phi prime is equal to phi, so the nodes are the same, and then for each edge E we construct an undirected edge E prime such that the st of E prime is equal to the set containing se and te. That is, E prime would be the undirected version of the directed edge E. Of course, if the source of E and the target of E is equal, that is the directed edge E is a loop, then st of E prime contains only a single node and it's also a loop. Yeah. So to repeat, the underlying undirected graph of a directed graph is simply the same, the graph with the same set of nodes, and the edges are connecting the same nodes but without direction. Now, if that means the number of edges and nodes in both the graph and its underlying undirected graph are the same. If the directed graph has an edge from A to B and an edge from B to A, then the underlying undirected graph would contain parallel edges between A and B. So let's see some example. So here's an example of a D graph on the left. So you have 6 nodes and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges, and the underlying undirected graph is essentially the same graph but without direction. So essentially, for example, for the edge from A to B, we remove the arrow, so we just have a line segment here. Also, for example, we have 2 edges, parallel edges from B to E here, then we have parallel edges here without directions. On the other hand, we also have an edge from C to D and D to C, so we have parallel edges here between C and D in the underlying undirected graph. So you simply take the same graph and then remove the direction, so that from that you get the underlying undirected graph. So this is pretty simple operation. Now the second operation, the subgraph operation, that is, from a graph we could define a subgraph. A subgraph of a graph is simply another graph where the nodes are the subset of the original graph and the edges, the set of edges, is a subset of the original set of edge. If you get a proper set in any of those pair of nodes or edges, then the subgraph is actually a proper subgraph. Now sometimes we want to take a subgraph of a graph by considering a particular set of nodes. So if you have a graph G and a set of nodes W, which is a subset of V, then the induced subgraph of G with respect to W is a subgraph G where the nodes are those in W and edges are those from E that connect only nodes in W. Yeah. So that's induced subgraph. Note also, if G is subgraph of H, then H is supergraph of G. So to clarify these two concepts, let's see an example. So you have this graph consisting of 5 nodes, and it's actually a complete graph K5, right? So let's find an induced subgraph with respect to the set A, B, and C. So essentially what we want to do is we take these 3 nodes, yeah, because you want to induce a subgraph with respect to this set, and then just take this part of the graph and the edges that connect this. So this one, and this one, right? So that will be the induced subgraph. So this is the result, right? So here is the result. Yeah, here. So you take the set of nodes A, B, C, and only take the edges from the original graph that connects only those A, B, or C, any pair of those 3. Right, so that's induced subgraph with respect to a set. So let's do some exercise. So this time we are given a directed graph. Now find an induced subgraph with respect to the set A, C, and E. So try this exercise first, and then when you're done, we shall discuss the solution in the next video.